Namaskar, welcome to Monastic online class. This is me, Jay Narayan Sir. Today we are going to discuss about the topics force of subject science of grade 10. Students, in these topics, in previous classes, before 10 class, you read about the different kinds of the force like frictional force, viscous force, muscular force, retarding force, braking force, so on. But here in this class, we study about different kinds of force. Like in our daily life, we observe different types of things. Like when any object falls from certain height, it falls downward. Why it falls downward? Why does not move upward? Besides this, planets revolve around the sun. Satellites revolve around the earth. How it revolves around it? How planets revolve around the sun? It means there exists some kind of force between them, and due to this, the planets revolve around the sun, satellite revolves around the planets. Besides this, we observe the tides on the sea, oceans. Why it appears? It means there exists some kinds of force. About the study of this, Sir Isaac Newton formulated the law about it. That law, everybody in this universe attracts every other body by a force. That force is known as gravitational force. And this gravitational force is directly proportional to the product of the masses of these two bodies and inversely proportional to the square of the distance between them. Everybody in this universe, like these duster and marker, in between them also there exists a force, but there is a small force. That force is not noticeable, but if the body is big, like Earth and Sun, like Earth and Moon, then that force is noticeable. But everybody, like even a small body or bigger body, there exists a force between them. That force is known as gravitation force, or we simply say gravitation. Here in these topics about the force, we discuss about the gravitational force. The first, what is gravitational force, what is gravity, and what is the Newton's law of gravitation. The first, right? Gravitational force. The force of attraction between any two bodies in the universe is called gravitational force or gravitation. Gravity. The force by which Earth attracts the body towards its center. Is called force of gravity or simply gravity. If two bodies are smaller, then you can see the gravitational force. But one body is bigger like Earth and body, then Earth attracts the body towards center. That is called the gravity or gravity of the Earth. Besides the gravity of other planets also, if the planet attracts the body towards center, then it is called the gravity of that planet. So here we are on the Earth, so we are discussing about the gravity means simply Earth. The force by which Earth attracts the body towards its center is called force of gravity, or simply we can say gravity. About this, Newton's formulated the law that is called Newton's law of gravitation. What is Newton's law of gravitation? Newton's law of gravitation. It states that everybody in this universe attracts every other body by a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. In 1687, Newton formulated this law. Every body in this universe attracts every other body by a force. That force is known as gravitational force, which is directly proportional to the product of their mass and inversely proportional to the square of distance between them. Now, explanation of this. Explanation. In the figure first, here two bodies A and B are taken. Body A has the mass m1, body B has the mass m2, and d is the distance between them. According to Newton's, the force of attraction, Newton's law of gravitation, the force of attraction F between them is directly proportional to the product of their masses. Means F proportional to m1, m2, and inversely proportional to the square of distance between them. The distance is d, so F proportional to 1 by d square, inversely proportional to the square of distance. So from this, what we obtain F proportional to m1 m2 by d square. This is the Newton's law of gravitation. We can write for explanation. Consider two bodies A and B of masses M1 and M2 respectively separated by a distance d apart as shown in figure first. If Fb force of attraction between them, then by Newton's law of gravitation, we can write F proportional to M1, M2 by d square. Means directly proportional to product of their masses and inversely proportional to the square of distance between them. If we remove this proportionality constant, we can write G. Where proportionality constant G is called universal gravitational constant. Its value is 6.67 10 to the power minus 11 Newton square meter per square kg, which remains constant throughout the universe. Students, this proportionality constant G is called universal gravity constant and its value is 6.67 10 to the power minus 11 Newton square meter per square kg, and this value is constant throughout the universe. That's why Newton's law of gravitation is also called universal law of gravitation, because this law is same, this law is true for every bodies in the universe. That's why it is called universal law of gravitation, where the value of constant G is fixed throughout the universe. That's why this law is called universal law of gravitation. Question may ask, state and explain Newton's law of gravitation. You can write to this one. Why? Question another way, question may ask in 1 marks, why Newton's law of gravitation is called universal? Because in Newton's law of gravitation, the value of constant G is fixed, is same for all in all over the universe. Its value is 6.67 into 10 power minus 11 Newton square meter per square kg, which remains constant throughout the universe. It means we can say the constant appearing in Newton's law of gravitation has fixed value, its value 6.67 10 power minus 11 Newton square meter per square kg throughout the universe. That's why this law is called universal law of gravitation. Now from this we can define the universal gravitational constant. How can we define the value of G? How can we define G? From this, if masses of bodies are 1 kg and distance between them is 1 meter, then universal gravitational constant becomes equal to force. And from this, we get the definition of universal gravitational constant. Definition of G. We have F equal to G m1 m2 by d square. Here m1 and m2 are the masses of two bodies and the distance between them. And according to Newton's law of gravitation, F equal to G m1 m2 by d square. Already we discussed. If m1 equal to m2 equal to 1 kg and distance between them d equal to 1 meter, then from equation first we get F equal to G into 1 into 1 by 1 square. Therefore G equal to F. So from this, what we can write? This G is universal gravitational constant, and this F is the force of attraction. So what we can write? Universal gravitational constant G is defined as the measure of force of attraction between two bodies of unit mass. 1 kg mass means unit mass and separated by a unit distance apart. It means if the body has mass 1 kg and distance between them is 1 meter, then what will be the force between them? That force is known as universal gravitational constant. We can write the definition thus: universal gravitational constant is defined as the measure of force of attraction between two bodies of unit masses separated by a unit distance apart. In question we ask in 1 mark, what is universal gravitational constant? You can write universal gravitational constant is defined as the measure of force of attraction between two bodies of unit mass separated by a unit distance apart. Another way also we can define the universal gravitational constant. This universal gravitational constant G appears only in Newton's law of gravitation, not any other law. So what we can write? The constant appearing in Newton's law of gravitation is called universal gravitational constant. This we also can define the universal gravitational constant. Another definition we can write: The constant appearing in Newton's law of gravitation is called universal gravitational constant appearing in Newton's law of gravitation is called universal gravitational constant. The value of universal gravitational constant is fixed and remains constant throughout the universe. The value of universal gravitational constant is 6.67 10 to the power minus 11 Newton per square meter per square kg, already discussed, and this value remains constant throughout the universe. That's why Newton's law of gravitation is also called universal law of gravitation. Now, how can we obtain the unit of universal gravity constant? Unit of G. Unit of universal gravitational constant. From Newton's law of gravitation, we have F equal to G m1 m2 by d square. Therefore, G equal to F d square by m1 m2. In SI system, F is measured in Newton, d in meter distance, m1 and m2 are the masses that measured in kg. So we can obtain the unit of G. F measured in Newton, n d in meter, a square of it, you can write like this way, m to the power 2, and m1 and m2 are the masses, it is measured in kg, so kg into kg. You can write Newton a square meter per a square kg. It is in SI system. In CGS system, force is measured in dyne, and distance is measured in centimeter, and mass is measured in gram. So, in CGS system, it will be dyne a square centimeter by gram into gram. Dyne a square centimeter per square. The question may ask, what is the value of universal gravitational constant, and convert it, write the value of universal gravitational constant in SI system and convert it into CGS system. You can convert it. Question may ask, write the value of universal gravitational constant in SI system. Convert it into CGS system. How can we write the value of universal gravitational constant in SI system is
6.67 10 to the power minus 11 Newton square meter per square kg. That is G, value of G 6.67 10 to the power minus 11 Newton square meter per square.
Now question, convert it into CGS system. In CGS system, meter change into time, meter change into centimeter, kg change into gram. To convert it into CGS system, for this
G equal to 6.67 10 to the power minus 11 Newton square meter per square kg.
where in CGS system meter must be changed into time. 1 meter equal to 10 to the power 5 time. 1 meter equal to 10 to the power 2 centimeter. This is time square. And kg change into gram. 1 kg equal to 10 to the power 3 gram square. Then it will be
6.67 10 to the power minus 11 into 10 to the power 5 into 10 to the power 4 upon 10 to the power 6. 10 to the power 4, 10 to the power 6 dyne square centimeter per square. We know since 1 Newton equal to 10 to the power 5 dyne, 1 meter equal to 10 to the power 2 centimeter, and 1 kg equal to 10 to the power 3 gram. From this 6.67 to 10 to the power minus 11, then 10 to the power 5, 10 to the power 4, all bases are same. So if you simplify it, then how much it will be? 5 for 9 and 6 goes up, then minus 11 minus 6 minus 17 and plus 9, then it will be minus 8. 6.67 10 to the power minus 8 dyne square centimeter per square gram. This is the value of universal gravity constant in CGS system. In this way, we can convert the value of G from SI system to CGS system. Now, here in Newton's law of gravitation, we discussed the Newton gravitational force directly proportional to product of the masses of two bodies and inversely proportional to the square of the distance between them. It means gravitational force depends on the masses of the bodies and distance between them. The value of G is fixed. So, how the gravitational force change if the masses of bodies are changed, if the distance between them is changed? Means the question, the relation between gravitational force with its factors like mass and distance. Gravitational force depends on two factors, mass and distance. The relation between gravitational force with its factors like masses and distance. We already discussed the gravitational force of attraction between two bodies of masses m1 and m2 separated by a distance d apart is given by f equal to gm1 m2 by d square. Now if the distance are
double mass of the bodies remains constant, then what will be the gravitational force? If the masses of the bodies are same, distance remains fixed, then what will be the change in gravitational force? How can we obtain? Force is factors like masses and distance. How gravitational force change if the masses of the bodies change, distance between them is fixed, or distance change, mass is fixed. We know the gravitational force here between two bodies of masses m1 and m2 separated by a distance d apart is given by F equal to g m1 m2 by d square. If some conditions related to special cases, first, if masses of both bodies are double and distance between them is fixed. Distance between them is fixed. If masses of both bodies are double and distance between them is fixed, then how the gravitational force change? If masses of both bodies are double, distance between them is fixed, it means that is mass m1 dash equal to 2m1 and m2 dash equal to 2m2 and distance between them is fixed, d dash equal to d. So what will be the new gravitational force? F dash equal to what? So from definition, we have F dash equal to g m1 dash m2 dash by d dash square. Because masses are same, distance is d, so d dash equal to d. So g m1 dash equal to 2m1, m2 dash equal to 2m2, and distance between them is 3, d dash equal to d, d square. Then it will be 4 g m1 m2 by d square. And g m1 m2 by d square equal to f. So it will be 4f. It means the distance between two bodies is fixed, but masses of both bodies are double. Then gravitational force increased by 4 times. So what question may ask? What will be the change in what will be the effect of gravitational force between two bodies if their mass is double than the previous mass? Then gravitational force is increased by 4 times. If the masses of one body is doubled, other masses of other body is fixed, distance is fixed, then gravitational force will be changed by 2 times. Gravitational force will be increased by 2 times. One of the factors, gravitational force depends upon the mass of the body. If the mass of the body is changed, then gravitational force also change. If the distance fixed, mass increases, gravitational force increases. Mass decreases, then gravitational force decreases. Another factor, if the mass of the body remains constant, but distance between them is doubled, then what will be the effect of gravitational force? Second case, if masses of bodies are fixed and distance between them is half.
that is d dash equal to d by 2. Distance is half, but mass is fixed. Then what will be the effect on gravitational force? Then we have F dash equal to, and mass is fixed, g m1 m2, but distance d dash square, the distance so d dash equal to d by 2. So g m1 m2 d dash equal to d by 2 square. Then it will be d square by 4, 4 goes up, 4 g m1 m2 by d square. It means for your gravitational force is increased by 4 times. If distance between them is half, but masses of the bodies remains constant. Now, third case, if masses of the bodies are fixed and distance between them is double. Third case, if masses remain same, if m1 dash equal to m1 and m2 dash equal to m2, and mass is fixed, distance d dash equal to double 2d. Then we have f dash equal to g m1 dash m2 dash by d dash square. G m1 dash means m1, m2 dash m2, d dash 2d. It will be 1 by 4 g m1 m2 by d square. Means 1 by 4 g m1 m2 by d square, already discussed dgf. So 1 by 4 here. It means if distance between them is doubled, then gravitational force decreased by 4 times. Gravitational force equal to F by 4. In this way, the gravitational force change if the masses of the bodies are changed and distance between them is changed. If the masses of the bodies are increased, then gravitational force also increased. By how many times? We discussed here. Similarly, if the masses are fixed and distance between them is changed, if the distance between them is doubled, gravitational force decreased by 4 times. Distance between them is half, then gravitational force increased by 4 times. In this way, gravitational force related with the masses of the bodies and distance between them. Related to this, so many numerical problems from the Newton's law of gravitation, F equal to g m1 m2 by d square. We can discuss so many numerical problems from the book. Students, you can solve the numerical problems. Next day we discuss the numerical problems related to these topics and another relation between gravitation, extension due to gravity and gravitational constants. Next day we will discuss about it. Today, this much. I hope you will get benefit from this class. Namaskar.